Hi, my name is Salase Dumenu. My partners were Francisco Burgos and Mintron. This is our ENGI 430 final team project, and our topic was optimizing roof selection. The reason why we chose this article was because first we were looking for a topic that related to us as engineers, and then roofing is something that engineers, contractors, architects, and surveyors deal with, especially with building and facility planning. Our DSS will help users select optimal roofing to ultimately satisfy the consumer in the long run. What we mean by that is we're hoping that our DSS helps them to select the most optimal solution based on their location to ensure that they save money or minimize costs. And then we'll be comparing or considering attributes like energy, efficient roofing materials. And we're hoping that this can be applied to companies that deal with roofing budgets. Now, for problem description, we know that optimal roofing materials are very important, and they're complex, and there's an extensive range of criteria that need to be considered, and we're going to be grouping this into a qualitative and a quantitative criteria. And our DSS will evaluate the qualitative and quantitative aspects of the different roofing options based on their properties or input characteristics for each. And then at the end of the DSS, it will generate or provide information in tabular and graphical form intended for the user to make the most optimal selection out of the ones that we provide. This is our homepage, and if you look at it, it gives you a description of the DSS and how it runs, and then the button at the bottom is the Start Demo button, which is the button that allows you to start the program or the DSS. This slide shows a snippet of our Access database, and the name of our database is Roof Data. And we have 15 different criteria or inputs that are generated in this data table, and we have 7 types of roofing or roofing options. We put some of the inputs in here. You can see obviously the first 5, but the ones that you can't see, like maintenance costs, thermal performance, and weight and thickness, are further to the right of that table. And this table is pulled into Access before the program is run. And the next slide here shows you the Access connection that we established in Excel. And this is just a macro. I'm only going to touch on 3 of these for the sake of time. This line of code right here was added into this code just to make sure that whenever the data is pulled, it first deletes whatever. If there's an old one, it deletes it, and then brings in the new one. That way you're guaranteed to have the most updated database from Access into Excel before the program is run. This is just the source that lets you know which file or folder from the computer that the database resides and is being pulled from. This was a bit tricky because when we did it and we're transferring, it was a bit iffy doing it from one computer to the other, but we figured it out and now it works fine. This is just the query that we used, and again, since we were pulling everything from the Access database, the whole table from the Access database, not just the numbers, we just used the select from roof data SQL query, and that allows us to get every single column from and every single row from the roof database in Access. Min will be talking about the next slide, which is a bit further into the program.
So to continue, I will show you the roof data before and after the connections. So this is the blank sheet of data. We keep a blank space for our roof data, and here is the roof data after the connections. It's all filled with the data automatically from the Access that we created. And here is the navigation user form we use this form for user to easier to navigate through the system. So we have the home page, the roof data page, the phase 1 page, phase 2, and also the statistical analysis page. The code is in here. This is not very hard coding. It's just to show the worksheet whenever the user click on the button. And here we go to phase 1. So phase 1, we have a user form for user to input their maximum temperature, minimum temperature, sustainability, and life expectancy that they want. And so we compare those from the what we have from the roof data, and then we get to the differences in here, and then we calculate the RMSE. But also, we put the weight into each of these to see which because thermal performance is the most important factor, so we time 10, so it will have more influence on the RSME score. And also for the sustainability, we just, and also for the life expectancy, because the year is very high, so we have to divide it by 30 to make it equal to sustainability and thermal performance. And here is the form, the phase 1 form. So basically, the user will enter the high temperature, low temperature, average high temperature, average low temperatures, and we also have the label for the user to easier to know what to do in here. And also the user need to put the millimeter of rainfall per year and desired life expectancy of their roof, what they want. And here is our code for that. So this is the forecast button. Also, so in here, they would take A3 is the highest high temperature minus the low temperatures, and also for the C3 we said that it would not be less than 0 or more than 100 year. And here is the coding for all of those. So basically we get all the informations from the user form, and when we use it, so if the A3 is less than, then we get the thermal performance to be 0.1, and it will be from 30 to 40, it will be to 0.2. The thermal performance will be 0.2, and if it's from 40 to 50, the differences in the temperatures, then the thermal performance is 0.3 and 0.4. And also we do the same thing for B2. If it's less than 200, then we get it to be 5. The sustainability score to be 5, and 200 to 500 is be 7, and more than 500 that would be 9. And then we assign those to the worksheet that we have in here. And also we have the message box to show the user like what is the best. And also this is a function we create to get the result strings, which is in here. Here's a function that we use to get the address of the result, and then we call our message box by that.
In phase 2, the quantitative attributes are measured. The user can use a spin button that decides how much coverage is needed. In turn, this affects bundles used, material costs, and labor costs. So in the upper chart, you see the initial cost of each type of roofing, the bundle coverage of each per square feet, and then once you change the square footage needed to cover with the spin button, here in the demonstration you'll see that the number of bundles needed and the total material cost will vary depending on how much you need. Then you will click on view completion, and then it'll show you that in this lower table of each installation bundle you can create your own. The user can put in the own amount of hours it takes to install each bundle, and then it'll tell you the total amount of hours it will take and then the labor costs for that. So behind this is the completion time user form and code. So in the completion time user form,
the user will be able to read the top label and understand why this is appearing, and will be able to enter the hours it takes to complete a bundle in each text box for each type of roofing, and then they can either accept and continue with that or cancel. So values entered in the text boxes are added into the ease of installation table from the previous slide. So this is the sub that makes it happen. So whatever value the user puts in the text boxes, it fills in those cells from the lower table in phase 2. And then you can click cancel to end. In the statistical analysis, which is the final sheet that you want to go after you finish phase 2, shows the top 3 recommended roofs with type of material they're made of. And the costs are shown according to each roofing type, and then as you can see in the red triangles in the upper right corner of the information boxes, you can hover over those and it'll show you recommendations that I will explain later in the demonstration. And the whole analysis table was completely made using VLOOKUP to get the values for RSME, the total weight of the material, the thickness, the material type, material price, and actual total price. So now going to our live demonstration, I'll go into the Excel file, and here is the welcome page or the home page, and you could start the demo. Here you'll see that no information from Access has been downloaded. You see how this affects the other data table. So without accessing the data from Access, there's no information shown in these tables, as you can see. And all these tables are connected to each other based on the roof data table from Access. So now we can go back to the roof data page, then access roof data. Then you want to adjust the table. It makes it look nice and makes the values look correct. And then you can navigate now to phase 1 of the page. Here in phase 1, it focuses on the qualitative attributes of the roofing. So here it'll tell you tell the user what this is for. So you can put the average high temperature for that region that the construction will be made in, and the average low temperature. And then you can put the millimeters of rainfall per year in the area, so we'll put 235, and then the desired life expectancy of the roofing, so we'll put 50. And then you can forecast this, and then it'll choose the best result depending on the lowest RMSE. And the result is a classic rib steel roof panel. On the right is a bar graph that shows the RMSE scores for each of the roof types. Next, the user can go to phase 2, and then here select the square footage needed to cover, or the amount of square footage of material needed for the construction to be completed and done correctly. So we can go up to 1,200 square footage needed, and as you can see, the number of bundles change according to the total area, and then material cost changes as well. And then down here in the lower table is ease of installation for each bundle. So basically the user can input how long it takes his team to input a bundle or complete a complete bundle. And then here you could just put in an estimated time of how many hours it takes. Accept and continue, and then as you can see, the total hours vary as a result of the ease of installation, and labor costs varies on that as well. Then you can navigate to the statistical analysis page, and here in the statistical analysis page there's a little text box that explains that you can compare the top 3 recommended roofings based on their RMSE score, their total weight of material, their thickness in inches, the material type, that they are made out of, and then the material price. But when looking at the cost, the quantitative aspect of the material, you want to look at the total actual price. So here, the actual total price includes material price plus labor cost plus maintenance cost. But there are also other aspects that the user may want to look at, like total weight of material. Transportation costs might be included in transporting these materials to the site or to a storage location. So most trucks have a weight limit, so this factor helps when considering how much can be transported in one trip. And if the cost doesn't matter to the user, then they can look at the RMSE score of each recommended roofing, and basically it just gives them a reminder that the lower the RMSE, the better the sustainability and thermal performance for the weather type selected from user in that region. So these are all the aspects that relate back to these top 3 recommended roofings that help an architect, engineer, contractor, surveyor, or a self-builder decide on optimally choosing the best roofing or choosing the best roofing for their customer. So lessons learned is work with enough time on hand. By practicing, you can make better models of decision support systems. When you work with groups, this allows you to have more creativeness and quality to be integrated. And then make sure to save access file and Excel file in the same folder, and make sure URL connection is correct. And ultimately, there are always different ways to make the DSS better. Applications to the real world: architects, cost engineers, quantity surveyors, and self-builders are potential users of the system. It has the problem of assisting them in selecting optimal materials from the list of alternatives based on the level of importance of the criteria set by them. Thank you.